Hey, yo, what's up? Wait. Who's that? Who's that? Who's that handsome, beautiful person? That's me? That's me? Oh, what can I say? Hey, yo, what's up, everyone? It's your boy, JOSHABRHAM. We back. Back. How you doing? How you doing? You're not doing? Oh, okay. I'm just asking. I'm just asking this normal stuff, bro. I'm just asking, bro, or whatever. I'm just asking the normal things, brother. Ain't nothing. Ain't nothing going on. Oh man, I should say I miss streaming. I miss streaming, gang. I really do. Fucking ads. What? What? Why I got some fucking ads, mate? Why I got? Why I gotta deal with ads, mate? Oh, they're capitalizing off me. That's advertisement. Ah. But my camera just gave up? Damn. 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 Damn, son. Okay, focus. Focus. Focus, focus. No, bro, that ain't it. That ain't it. Oh man. Oh, okay. Where was I? I was on experiment. Fuck. Yo. The way chat replied makes me believe you are below average in actual intelligence. Yo, Roy with PL5CG. Not gonna lie. Ain't gonna lie. I kinda agree. I gotta say, my intelligence is not very good. My brain takes a little bit time to understand, to see the patterns. It takes a little bit time. But hey, we gotta live, right? It don't matter. It don't matter if it takes a little bit time. We got all the time in the... You know what? I should stop talking because, again, it's nighttime. People tend to talk a lot at nighttime. So I'm a But hey, Roy Witt, you were spot on. God damn. God. Lock in, gang. Hey, yo, EJB, what's up? Appreciate the support. Ain't gonna lie, appreciate the support. What is your first language? You mean native language? It's a language called Malayalam. Hindi. I do know a little bit of Hindi, but my native language is Malayalam. What's up, cracker? Hey yo, EJB, I did not expect you to check out the stream, but hey, here you are. That's crazy. So let me see, where was I last time? Determination of chloride. Oh, I did not... That's all I wrote. Just the heading. I gotta say, past me did do a lot. But I do remember the Nernst equation. Why the log concentration of the ion used. The log concentration basically measures the entropy factor. The factor in which entropy changes according to the change in concentration multiplied by the volt. This was Malava, you said. Malayalam. It's a palindrome. If you spell Malayalam backwards, it's gonna sound the same. Yo, my camera just gave up. Fuck. Yes, EJB, you got it right. Oh, you got that right. Yes. So that was this log, basically, and I was looking into why we were subtracting. It's spoken in Kerala, right? Yep. It is a language spoken in the land of the land of the gods, the God's own land, God's own country. You know where I'm from? Looks like you almost got it, so I'm guessing you're from India. But which part of India though? I don't remember exactly. Apologies for the camera, okay? I don't know what's going on. I'm from across the border. I got Tamil Nadu. Whoa. നീ എന്തുകൊണ്ടാണ് ഇത്ര സുന്ദരമായി കാണപ്പെടുന്നത്? Oh, damn. That's some good ass Malayalam, gang. ഞാൻ എന്തുകൊണ്ടാണ്? എന്താ ചെയ്യാ? What can I do, fam? What can I say? So from across the border. Across the border. ഞാൻ അത് സംസാരിക്കും. Oh, okay. It's not from Google Translate or some shit. Okay. Oh, you mean border, like not state border. Oh, okay. Country border. Okay, I get it. Oh, I thought you were from India. But hey, Pakistan, we're kind of the same, bro. We're all from the same place, almost the same place. Oh, you do speak the language. Oh, you know the lingo, huh? I gotta be careful. Yeah, I remember. I remember asking this. Why is this plus the entropy factor multiplied by the volt is used? E0 represents intrinsic standard electrical push of chemical reaction when everything is completely balanced under strict A strict laboratory condition. Yeah, we're the same people, same culture, same face, just divided by stupid politics and stupid border. Yeah, I agree, EJB. There should not be a conflict. Conflict seems so stupid. I mean, I agree. Conflict exists. Oh, it's nighttime. Okay, if I talk too much, apologies. Because again, I always say this. Whenever it's nighttime, people talk too much. People get more emotionally vulnerable, which leads to a lot of stupid stuff. But again, I gotta say, conflict is good, but finding solution to conflict, that's what this is for. Not to pour as or pour petrol onto conflict. It's easy to make a conflict big. Roy Witt, you're from Punjab. Ah, Punjab. Punjab. Ah, what the reference do I have of Punjab? There's a Malayalam movie called Punjabi House, but it's like okay. Let's go. That's cool. Yo, my camera, bro. What's going on, gang? What's going on? Wait. Just a minute. I'm gonna disconnect, and I'm gonna connect again. Just a minute, gang. Because this is not it. Continuity. This time it should work. It worked. Ballet. Ballet. E0 represents the intrinsic standard electrical push of chemical reaction. E0 represents intrinsic standard electrical push. Okay. It's when everything is completely balanced under strict laboratory conditions. Think of E0 as a chemical identity of your system. It depends entirely on how badly the specific chemical element involved want electrons. Okay, so the ion, okay. For example, so it's more like a standard value. Yeah, it's a standard potential. So E0 is gonna be same. So it's just like the name. It's a standard, and let's take Ag plus. So E0 of Ag plus, does it oh yo, the camera just okay, I don't even care. Does it depend on what? Does it depend on oh god damn it, did I just depend on the concentration, or it only depends on how the element works, element's electronegativity negativity. Oh come on, what do you mean? Yo, I can't proceed further. I gotta start again. No. Let me. at standard conditions, concentration ratio is 1 because ഞാൻ ന്യൂഡൽഹി നോർത്തേൺ ഓ ഫക്ക് ഏരി ഏരിയയിൽ ഏരിയയിൽ നിന്നും 280 മൈൽ അകലെയാണ്. ഓക്കെ, 280 കിലോമീറ്റേഴ്സ്. മൈൽ എന്ന് പറയാൻ is mile in Malayalam miles? American unit miles? Oh, okay, understandable. I gotta say, I need to improve my Malayalam, because it took me a while to read Ariel. But don't worry, we're gonna improve the native language support up here. We're gonna improve it. I'm gonna improve it within next month. How? You'll see. Oh, okay. Oh shit, okay. But it's said mile. അല്ല 280 mile. Yeah, okay, it's said mile, but it's kilometers. Oh, I did not know. Okay, that's interesting. Usually it should say kilometer. Ka I la o ita mi ita kilometer. But was it? Oh shit. But interesting. I did not know that. I did not know that mile is kilometers when you translate to Malayalam. Bro, this guy is sending me voice messages. But it stands for walking distance. I gotta confirm this with my creators, not gonna lie. So from what I understand, this value depends on the concentration and the electronegativity. Of the said compound. Electronegativity of said compound? No, electronegativity. Fuck. Actually, E0 does not depend on the actual concentration. Fixed baseline value where the concentration are already locked in by scientists. Okay, so what does it depends on? Electronegativity. Okay, it's mainly dependent on electronegativity. Okay. Yo, you are studying physics? You have major in physics and biochemistry. Okay, interesting. Right now I'm on my bachelor's on biochemistry. What is my question? My question was, in this Nernst equation, how when we subtract standard electrode potential with This term is basically, what is this? This is the volts and log of concentration of the ion involved. Why are we subtracting this? And what's with the E reference? Like, I have an oral exam coming up, and I should expect questions from all side, every side. He could ask me, yo, tell me next equation. Why? What does it mean with the log of Ag plus? What does that mean? So I could be asked any type of question, even if they don't ask me any hard questions. I still need to know, because my stupid brain does not understand what is still going on. Could you explain then how is this equation valid? It tracks how changing concentration, okay? You might wonder why it's a plus sign instead of... Oh, it's a plus sign, yeah. Yo, bro, I don't... not gonna lie, reading in Malayalam is gonna be a bit tough because everything is... വേരിയബിളിൻ്റെ ഉയർന്ന സാന്ദ്രത കാരണം നിങ്ങൾ അത് കുറയ്ക്കുന്നു. വേരിയബിളുകളിൻ്റെ ഉയർന്ന സാന്ദ്രത സാന്ദ്രത കാരണം നിങ്ങൾ അത് കുറയ്ക്കുന്നു. You subtract E because of the density of the variable, which is still E. Density of the variable, which is still E. He's telling you to addition, it is subtraction. Oh, it's not addition? Wait, what? Simple mathematical property of logarithm. Why is it now 1 by A? What? Pure solid silver on the top is constant and is written as... When you flip a fraction inside a logarithm, the sign changes inside. The sign inside changes, okay? Because the silver transfers exactly 1 electron, dividing 0.0591 by 1 leaves it unchanged. This simplifies the equation. Why is the E reference doing there? In real laboratory settings, you cannot measure the voltage of a single solution using only one metal wire. You need a complete circuit, which requires a second electrode called reference electrode, yeah? Such as saturated okay. E is the variable. When you apply it over a fraction, it becomes S, which is the solution to Cramén's conjecture. What is Cramén's conjecture? What the new terminologies? What is Cramén's conjecture? Cramén, okay. S becomes a solvent which translates. You have to find S at your study level. That is what they're teaching. I will not give you the answer. Oh, okay. I mean, I appreciate the ball knowledge. It's the part I need to understand more on this. The more I learn, the more I understand that I don't know shit. Where did the subtraction go? The plus sign explained. Original Nernst equation for the silver reduction is written as, so Ag plus on top, it's pure solid silver on the top is a constant, as it is written as 1. Why is it constant? I don't get it. It is profound for your study. Understanding this? Yeah, I guess so. Why is it constant? I don't know. When you flip a fraction, it's why though? Why is this solid? Very good question. It's gonna treat it as a constant because its concentration never changes, no matter how much of it you add or remove. Concentration means crowdedness. Concentration is defined as the amount of substance divided by the space it occupies. For dissolved ions, you can add more water to make them less crowded. Yes. Evaporate water to make them less crowded. Okay. Make them more crowded. Their moles to volume ratio changes constantly. For a pure solid, the silver atoms are tightly locked. Yeah, if you cut the block of silver in half, you have the number of moles, but you still also have the volume. The density and the crowdedness of the silver atoms inside the solid remains exactly the same. Okay. My brain is not fully simulating the what. Here is a bigger hint. If E observed equals E not observed, the chemical compound is unstable. Unstability is S, which they want from you. Okay. Potential observed. Constant is 1 always. Again, like I was saying, I'm having a bit hard time imagining why it's 1. If you cut the solid silver in half, you have the number of moles, but you still have the volume. Concentration is number of moles by volume. If you cut a solid silver, you have the number of moles and the volume, so the fraction remains the same. The concentration remains the same. I see it, but why is it not a distinction in others? Scientists factor directly into baseline standard potential itself to keep the math clean. The standard state convention assigns a value of exactly 1 to any pure solid or pure liquid. Pure liquid without any sort of like if it's all the same compound, I'm guessing. What does this does to math? when you write the reaction quotient, replacing the unchangeable silver solid with 1 simplifies the expression beautifully. Oh, you had to use the word beautiful. This allows the Nernst equation to ignore a chunk of silver metal entirely, focus on its mathematical attention. Okay, that was just a question on why the a solid is fixed. If you hold ice in your hand, the melting of the ice is moles. Cramén's conjecture by joules. Moles by joules. Moles by joules as in therefore always equals 1. Yeah, I kinda understand the 1 part. I is S in chat's terminology. Where's I though? So I understood the why pure solid silver is considered as 1. When you flip a fraction inside the logarithm, sign changes since the sign outside changes. Okay. But this here is 1 because pure silver forms. But what if it's not pure silver? I'm having more confusion on the entropy factor. Product by reactant concentration, the division of concentration of product by reactant. What do you get if you log 10 not I or not 1? Log 10 not 1. Okay. When you flip a fraction inside the logarithm, the sign changes outside because silver transfers 1 electron, exactly 1 electron, leaves it unchanged. Ooh, silver transfers exactly 1 electron. Okay, from this equation. S equals log 10 times the stability of the metal. You mean? Did you mean S as in entropy? I'm guessing the S you meant is entropy, right? What is he referencing there? So it's just a. So the real equation is minus. Okay. When I say S, it means log 10 times the stability of the metal. Stability of the metal as in No. So I'm guessing it means I said something wrong. Please correct me if I did, because again, I'm open to different sides to the same equation. S equals log to the base 10 times 1 by metal's stability. 1 by metal's stability. Again, metal stability as in stability. What the is the stability you're talking about? What's the factor? Is it like when you say stability, first thing comes to my mind is entropy, but entropy is not it. Then stability as in electronegativity? No, I don't think so. Yo, I still got a lot to learn. In real laboratory setup, you cannot measure the voltage of a single. Oh, that's the E reference. So here you get this equation just from changing some stuff. And basically this equation gives you the entropy factor. I understood that one. The log to the base 10 times concentration of the ion is the entropy factor. I do remember that one. How much energy it puts off every metal decays. Energy they put off. Energy they put off as in what entropy is close. But like you said, energy that it puts off. It's like I wouldn't say like radiation, but okay. So that's almost. I just need to read the last part too. In laboratory, you cannot measure the voltage of a single solution using one metal wire. You need a complete circuit, which requires a second electrode called reference electrode, such as saturated. Yeah. A reference electrode is specifically designed so that its chemical environment never changes. Therefore, its voltage E reference is a perfect constant fixed number. The total measured voltage, a voltmeter. Radiation. Yeah, radiation is a more broad term. Could you say that everything? Yeah, you could say that. Very, 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 very small radiation. You need a complete circuit which requires a second electrode called the reference electrode. Reference property. Reference electrode is specifically designed so that its chemical environment never changes. I'm confused on this part. Put it all together. E measuring minus E reference. Oh, okay. So E observed equals E measuring minus E reference. The reference electrode is 1. I mean, for my case, I think reference electrode is 0.80, but it's mentioned here. Termination time. No, it's not mentioned here. E0 are completely fixed. Only variable that can alter the voltage on your screen is concentration of silver ion. If you dilute the silver ions tenfold, the log term drops by 1 and the observed voltage drops by exactly 0.591 because of the entropic loss of chemical pressure. E reference electrode is always 1. Oh. Okay, then I need to recheck on that because I feel like I read somewhere it was 80. It's not written anywhere. So concentration of silver ions is what it is a constant. It is saying it's fixed. Yeah, I know it's fixed, but the fixed value was 0.80 from what I remember. Let me ask it. Oh, the reference electrode was 0.20. The entropic loss of chemical pressure equals radiation. I mean, there's the which law of thermodynamics? Second law or first law, where entropy of the universe increases, right? So, in that sense, even a single element releases energy in a way that it contributes the increase in entropy of the universe or the system, I guess. It should. Okay. It is fixed at 0.80 due to the loss of chemical pressure standardized by the silver. I gotta write this though. It should just E reference should start at 1. Okay. I almost start can you let me know more about one-year anniversary coming soon? Yes, 1 year. Oh, 1 year since I started studying. I gotta say, it's gonna go further. I'm starting to understand it. Let me know more about how the E standard and E ref work. Also, a bit. Also, I keep on forgetting important terms. Study for 24 hours on anniversary day. Nah. Nah, I'm good. But it's gonna be cool. It was 14th of August, right? I keep on forgetting unimportant terms like voltage. Oh, I got to. It's completely normal. What? Am I helping or confusing you more? No, no. Again, confusing is a bad word. I like to hear different sides of this. I wouldn't say confusing. Voltage is electrical pressure, water pressure. Oh, okay, okay. Low voltage means very little push, means electrons are perfectly still like water in a flat puddle. High voltage means electrons are highly compressed and pushing hard to move. Two anchors, E0 and E reference. To measure any kind of pressure or height, you need a reference point. For example, if you say mountain is 3000 meters high, you mean it's 3000 meters from sea level. For your equation, E0 and E reference are two different kinds of sea levels used to calculate the final electrical pressure. E0, intrinsic chemical sea level standard. Potential represents the maximum. Okay, E0 represents the max amount of we have all the beautiful mountains, waterfall scenarios, and someone invented chemistry. Yeah. Someone should invent chemistry. Think of E0 as a natural, unedited blueprint. Okay. I understood E0, E reference, physical comparison sea level. Voltmeter cannot measure a single point. It always measures the difference between 2 points. If you only put a silver wire into a solution, the voltmeter won't show anything because the circuit is open. Okay. To fix this, you drop a second independent electrode into the beaker. Okay. So the silver ions travel between these 2 points. I understand that. To fix this, you drop a second independent electrode into the beaker. This is a reference electrode. What does it mean? It is a self-contained sealed capsule that acts as completely unchangeable benchmark. Its voltage never change. No matter what happening in the rest of the beaker. Think of E reference as a fixed ruler that you stick into the ground so you can measure how much your silver solution voltage is rising or falling. Are you studying electrolysis? Is this electrolysis? I don't know. I'm actually studying So this is basically an analytical chemistry experiment where you find the chloride content in a sample using potentiometric titration. So titration using electrolysis, yeah. So titration using electrolysis, and my stupid brain forgot the whole thing, and I was recollecting why this equation, what is happening in general, because my memory is not very good. Putting them together in your equation. Look at how they lay out in your formula. Adjust how the baseline entropy is subtracted in at the very end simply because the voltmeter is calculating the physical gap between the silver side and your fixed benchmark. No, I don't need to do I'm still having hard time imagining how this reference electrode and standard interact. Gemini has to be best AI for students. I if you asked me this question, or if you said this statement like 1 month ago, I would have said nah, ChatGPT good. But I started using Notebook LM, and I gotta say that's far better than whatever the GPT is doing. And now I hate GPT even more because they made a new app, and there's limit. Back in like before this app, even if I reached the daily limit for the advanced model, they would still let me use the lower model. Now no, I can't even use the app until the next like time limit, some shit that fuck that. So yeah, I'm not gonna even touch GPT anymore. Gemini good, Gemini better. At least Gemini lets you use. I mean, I could still use GPT on the what's it called, the browser, but nah. GPT started getting greedy. Oh, AI companies getting greedy. That tracks. I prefer this one. What's the other AI you were talking about? Notebook LM. I think it's part of Gemini. At least it runs on Gemini. This one, Notebook LM. It is good. At least I find it good. Could you explain? Could you help me visualize how this? Because I'm starting to have wait, because I'm still not understanding how the flow of electrons through Ag plus is done between these two. My understanding right now would be that these two, standard and reference electrode, act it's not the positive negative terminal though. somehow makes the Ag plus travel between them, but I'm still confused on what makes them travel. I don't see a positive, negative terminal or anything. Gemini's thinking, oh, this dumb guy, bro. The terminals are created by the chemical reactions themselves, right at the surface of the metal. You don't need to plug this into a wall outlet to get positive, negative terminals. Just a minute. The reference electrode is the negative terminal. The reference electrode contains a chemical system that easily gives up electron. This leaves a pile of negative electrons on its wire, making it a negative terminal, positive terminal. What's the reference electrode here? Silver indicator electrode and reference electrode, okay. When you connect these two electrodes with a wire, you instantly create a highway between a pushing force and a pulling force. Right now, so reference electrode is the pushing side and silver indicator electrode is the pulling side. What makes the electrons flow? Electrons now swim through the liquid solution. Electrons only travel through the metal wire. The reference electrode releases electrons into the wire and negative terminal. Negative terminal as in the reference electrode. These electrons travel through the wire, pass through your voltmeter and arrive at the silver wire. Once the electron reaches the surface of the silver wire, the dissolved Ag plus ion in the liquid crowd around the metal grab the incoming electron and turn into a solid silver atom. So here it's okay. What makes ions travel? You mentioned the idea of Ag plus traveling between two electrodes. This is actually a slight misunderstanding. The silver ions do not travel to the reference electrode. They stay on their own side. Instead, they move because of the two distinct forces: diffusion, because of the terminal energy. Ag plus ions are constantly bouncing around randomly. If there's a lot of them around, they naturally bump their way towards the silver wire. Electrostatic attraction: as electrons pile upon silver wire, becomes a highly negative because opposite polar charges attract. Positive ions are physically bound, pulled towards the negative wire like iron filings to magnet. Okay. The salt bridge, the invisible highway. If positive Ag plus ions are constantly leaving the solution, turning into a solid metal, positive Ag plus ions are constantly leaving the solution, turning into solid metal, the solution would quickly lose its positive charge and become dangerously negative. Salt bridge, there we go. Electrolysis. Sketch out a text-based diagram showing, okay. Open, come on. I need to draw the whole thing because it looks like I don't understand. Could you again help me visualize the whole reaction, including the electrode, the standard electrode, the voltmeter, how the titrant is helping us, and how the CL is measured. After I visualize this, I will be able to understand the equations used here better. I got distracted again. To help you visualize the potentiometric precipitation titration of chloride, imagine a laboratory setup where chemistry clear solution containing your unknown chloride ions diluted with DNS water and a few drops of nitric acid. Okay. HNO3. Okay. The voltmeter. This is the brain of the experiment. Okay. Connected to two different probes dipped in the beaker. The standard reference electrode. Think of it as a steady lighthouse. It provides a perfectly constant baseline of 20 volts. It never changes no matter what happens in the beaker. How? The indicator electrode, think of this as a sensitive antenna. Its only job is to feel how many free ions. Every time the automated burette adds a drop, it's introducing silver ions into the mix. The silver ions want to find chloride ions to form a solid white sludge called silver chloride. The beaker is crowded with Cl- ions. Every Ag ion that drops in immediately snatched by silver minus ion and turned into solid precipitate. Electricity, because silver is trapped in a solid, there is almost zero free Ag plus ions from the silver antenna. Since the antenna feels nothing, it reports a low flat voltage around 240, 250. At equivalence, you have added exactly 1 Ag plus for every Cl-. There is no more free chloride left to snatch the silver. Suddenly, the concentration of free Ag plus ions in the water begins to shift because the buffer of the chloride ions are gone. The voltmeter detects a sharp vertical jump in potential, hitting this is the beep, telling the instrument that the reaction is finished. So when you add silver nitrate, it reacts with chlorine, forms a solid, deposits when silver nitrate into the solution, it reacts with Cl and it deposits as a solid. How does it deposit as solid when the solution has a potential what makes the Ag plus react with chlorine then or provide how does the maintained if to understand why silver reacts with chloride instead of traveling with electrons. The reason Ag plus immediately matter of chemical affinity. Silver adds extremely strong attraction. Yeah, precipitation reaction, not a redox reaction. Solubility of the silver chloride is low. They snap together to form a solid crystal. How potential is generated. The surface equilibrium. Potential differentiation is not caused by current flowing through the liquid. Instead, it's a static measurement happening at the very edge of the silver rod. Even though almost all the silver is turning into solid as sludge, invisible amount of Ag plus ions always remain dissolved in water, governed by the Ksp. At surface of the silver rod, a tiny number of silver atoms at the rod hop into water, and tiny number of Ag plus a tiny number of silver atoms from the rod hop into water. Okay. This creates a tiny electrical pressure on the rod's surface. The voltmeter doesn't use up these ions, it simply feels the pressure as long as there is one Ag plus ion left in the water. That pressure exists can be measured. That pressure exists and can be measured. How the potential difference is maintained. This works because two electrons are playing different roles. Reference electrode, Ag plus reference electrode is a closed system. Instead of it has its own silver wire, its own silver chloride, and a steady 3 molar KCl solution. KCl solution, okay. It is physically shielded from the war happening in a beaker, therefore its potential stays at exactly no matter how much precipitate you form in the beaker. This silver rod is exposed to the beaker. Its potential is determined by the Nernst equation, which uses the concentration of tiny amount of free Ag plus that hasn't precipitated yet. The silver rod is exposed to the beaker. Its potential is determined by the Nernst equation, which uses the concentration of tiny amount of free Ag plus that hasn't precipitated yet. Yo. I need to understand more on the reference electrode. This silver rod is. Oh, I gotta read this again. Okay, I got distracted. Fuck. Okay, I can feel my attention span kinda wearing off. What can I do? What can I do to get? Let me look up an old biochemical thermodynamics. No, not this. It's from past semester. Kinetics. Yep. Oh fuck. I remember drawing the whole. Where is it? No, not this. No, not this. No, not this. What should I search? Electro. Electrolysis. Yeah, there we go. There we go. There we go. What was this? So that's the AU. This is the origin. Okay, so standard potential works. I gotta write this. So it's negative. They give the electron in a way that it attracts the ions, and the ions form silver, the solid. So there's a layer of solid gold, and inside it's a layer of solid gold followed by the ions surrounding it to absorb the electron. And but this positive charge on the surface results in the so we got a positive charge. Counter anion to the solution is attacked by the partial positive charge on the surface of the results in the electrostatic attraction of negative ions. Okay, the negative ions in the solution. This polarized layer is called electrical double layer. Okay, this is the origins of standard potential. So this is a standard potential. I still haven't broke down what reference electrode. I gotta write that down. I gotta draw how reference electrode is working. I need to be able how exactly is this able to maintain its constant Your indicator electrode is like a sensor. And I need more explanation on how exactly is this able to sense that there's less Ag. Again, I understood that AgCl forms, so Ag, but and at some point, at equivalence point, there's still equal amount of right after the AG plus and resulting in higher voltage observed, but I still haven't understood how they observe it. Not they, the electrode, indicator electrode. What do you mean they? Yes, YouTube, I am interested. Let's go. That's what YouTube's all about. Sans fan, how you doing? How you doing? What was I gonna say? I was gonna say something. Yeah, this Tuesday. I'm doing good. How about you? Yeah, it's okay. I just got back from my work, and I got an oral exam coming up Tuesday, so I gotta prepare for that. And Tuesday, I'm gonna be playing a game called Team Fortress 2. Why? Because there was a person on Twitch and YouTube just keeps on coming up every time and tells me to play this game, and I was like, okay. Oh, you love the game? Oh, okay. So, like I said, I found a way to play Windows game on my laptop. We should play together. Oh, again, like I was saying, on Tuesday I will try playing this game. Um, and within that 30 minutes, I'll see if I like it or not. I'm not a big multiplayer type of person, but hey, maybe I'll like it. It's a shooter, right? But yeah, I'll try it out. Let's see how it is. Again, I don't know how compatible the game is with my computer, but let's see on Tuesday. On Tuesday. Yeah. Okay. So you know the game. I should try it out. I was gonna play Sleeping Dogs, but or Dark Souls, or Lights of P. Again, I still have to complete Undertale. I remember I was stuck at a boss. It was that robot, dancing robot. But hey, you have Dark Souls? Yeah, I had the game a long time ago, but it was not. The story is I somehow found a way to play Dark Souls on my laptop like 2 years ago. Then they stopped supporting this thing. But recently, like I told you, China found a way to let me play Windows game on my macOS computer. And Dark Souls works really good. I wouldn't say it's like perfect, but I could still play the game. That was cool. In that sense, like I could play Pal World. I should try it out. I can only play once a week, but once a week I'll keep on trying different games. Think of titration as an electronic tug of war. Okay, okay. Once a week? You must be the smartest kid in your class. What do you mean? Why? I'm the dumbest kid. Because my friends are already in Czech Republic studying their second year. It took me 2 years to complete my first year subjects. And I still haven't completed it. So I don't know if that speaks smart. But yeah. What the? Nah, it doesn't matter. See, at least you're doing your best. Yeah, that's it. I can't imagine myself sitting at least 1 hour consecutively to study. Well, 1 hour is nothing. So yeah. But yeah, this is how you learn, right? This is how you increase the hours. Fuck. Rally. There we go. I'll be doing this until 12:30. A brain not braining, bro. Timer till 12:30.
How long?
No, stupid. Why did I trust you? For 13 minutes.
13 minutes. Counting down.
Yeah. Yeah. Visualizing the reference electrode, the standard lighthouse. Reference electrode is designed to be a closed environment so its internal chemistry never changes regardless of what you do in the beaker. Construction: inside a glass casing, there is a silver wire that has been chemically coated with a layer of silver chloride. The wire is submerged in a very concentrated salt solution. Why is it constant? The electrode voltage is determined by the concentration of ions touching it. Because the silver wire is surrounded by a massive constant ocean of chloride ions, the equilibrium between the silver metal and the silver chloride layer is fixed. What do you mean by equilibrium being fixed? Can you what makes the equilibrium? The concentration of KCl being high makes no silver to silver metal to react. Is that what makes when we say equilibrium is fixed, we mean that the chemical reaction happening inside the reference electrode is a state of perfect, unchanging balance, because the environment inside the electrode causing never changes. The voltage it produces all stays locked at a specific value. Ow. Oh fuck. Why is it not? Oh fuck. That's not good. It should what happened to the spine? It should crack. Should I stand up? Just a minute, gang. That's so weird. I can't crack my spine though. Okay. What? But I tried. I feel like it wants to be cracked, but it's not. If I go too far, my intestines is gonna go different places. Okay. Focus. 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 Tug of war where silver chloride is constantly trying to turn into silver metal and release chloride, while the exact same time silver metal is trying to combine with okay. Where wire is submerged in a 3 mole KCl solution, there is a massive excess of chloride ion stability where the concentration of Cl- is so high. If a few ions are created or used up by the wire, it's like taking up a cup of water from the ocean. The total concentration doesn't change. Since the concentration of Cl never changes, hence the equation for this specific electrode becomes a constant. The equilibrium doesn't shift left or right. It stays exactly where it is, providing a steady 0.20 volts baseline. Okay, so it's okay, it's just what I thought. Not like my thoughts are always right, but okay. Yo. Beaker, magnetic stirrer. I don't. And connected to a voltmeter. Now I need to know if I got the signs correct for where the reference electrode connecting to the V is negative. now I'm drawing the reference electrode, and it looks like a wire covered KCl solution. Again, I kinda forgot how is this. I know that the equilibrium is constant, and after using the Nernst equation, it's gonna but I'm still a bit confused on how difference or the electron suction showed by the KCl layer. In your drawing, you are capturing the essential parts to clarify your confusion. We first should know that the value used in is not 9.2. Okay, I thought. Here's what the constant is maintained, how KCl layer functions as the anchor. The fixed internal equilibrium, there is a specific chemical balance that never changes. Reaction, yeah. Concentration, results is locked. Nernst equation, KCl layer and potential difference. You mentioned the electron suction or how the potential is shown. It is helpful to think that KCl layer is not a vacuum, but has a stable floor. Completing the circuit, the KCl solution acts as a bridge, while it physically shields from your sample. It allows for a tiny flow of ions through a porous frit at the bottom. This allows the voltmeter to complete the circuit without the solution mixing. No suction. There isn't actually any suction of electrons. Instead, the voltmeter is comparing the pressure of silver ions hitting your indicator rod against a steady pressure inside the reference probe. Okay, I need to understand a bit more on that part. But if I could get it, I feel like my professor is gonna ask this. Okay, I'm gonna end the stream, gang. And I appreciate you guys for checking out the stream. Respect. Peace. Yo, Sans fan, you're still here. Respect. Peace out.